Hello, today we are going to talk about for the course of data structure and algorithm. So this is the brief outline of the course that we will discuss the introduction, basic reviews of the programming concepts, overview, abstract data types, and types of the data structure. This is the outline for this lecture. So the objective is to understand the concept of data structure, distinguish between data structure and data types, learn how data structures are organized in computer, describe the characteristics of common types of data structure and understand the concepts of abstract data type, and then describe the disadvantages of abstract data types. So first of all, the introduction, study of various ways of organizing data in computer is the data structure. Data structure information is manipulated by systematic and step-by-step procedure called algorithm. And data structure manipulation involves adding, searching, deleting, rearranging data items. Data structures are used in several disciplines. Data structures are used by operating systems, compilers, database management, data communication, etc. And algorithms in data structure are algorithm together with data structures are used in several applications. Common applications of data structure are image processing, signal processing, simulation, numerical computing, cryptography, data compression, and genetic studies. Data structure and algorithms. Data structure is a way to store and organize data in a computer so that it can be efficiently used. Algorithms are used to manipulate data contained in data structure for searching, sorting, and traversing, etc. So data structure plus algorithm, they make some application. So applications are data structure applications are in image processing, signal processing, simulation, numerical computation, etc. Data structure and real life examples. And in real life examples, the different types of data structure that we use, they are the example of dictionaries, where the data is organized in the words and the meanings. Data is organized in the form of maps. Data is organized in the form of cache books and records. In computers, the data structures are used in computer science as operating systems, MSQL servers, and networking, data communication, and networking, and in the form of compilers. They use the data structures. Data types. Data types are required for efficient coding of the programs. Two types are primitive and composite. Primitive Two types are the primitive types and the composite types. Primitive data types includes the Boolean, which store logical values true and false. Operations on Boolean data, they include and or not operation. Integer type can assume different sets of values depending upon the compiler system. Basic operations on integers are arithmetic and comparison. Primitive data types are also called atomic or irreducible data types. The primitive data types are int, float, double, etc. These are the byte, short, int, float, long, double, boolean, and character. So these are the default values, size, and the range of these data types. Composite data types. Complex data types are defined using the combination of primitive data types. Composite data types can be arrays, vectors, or strings. An array is a collection of homogeneous data types. Vectors are mathematical representations of arrays. String is a combination of characters. In C or C++, and Pascal, and Pascal programming, string data are stored with a special delimiter. Fortran 90 and Visual Basic support strings as primitive data types. Basic operations on strings are assigning, joining, and comparing. And Java supports strings as built-in string class. Data types, primitive and composite data types are sufficient for solving simple problems. primitive and composite data types. The early computer applications depend on the built-in data types of programming languages. Primitive types are not always sufficient to solve advanced problems. The need for advanced data types arose due to the new paradigm of object-oriented approach. Data structures are meant to observe these special needs. Common data structures, as I mentioned, common data structures are arrays, linked list, queues, stacks, trees, and graphs. Data structure arrays are used to store the data, where there are the indexing for the arrays and there are the values in the arrays. For arrays, there is some base address and then the address goes ahead with the indexing. So the first element of the array is at address 1,000. Then the next one is 1,002, 1,004, 1,006, and 1,008. Applications are sorting simple records. Arrays are used to storing simple records. Then it comes the linked list. Linked list is a list where next element is connected with the previous element. Next element is connected with the previous element. So this is example of a linked list. This is a simple linked list or singly linked list where have some information and the link point to the next element, link point to the next element. Then there is the doubly linked list, which is connected to the next and the previous one. So the applications are storing dynamic frequent operations. Linked lists are used for storing dynamic and frequent operations. Then it comes the stack. Stacks are used to store the data. What is famous for the stack is for stack we use the push operation to put something on the stack and pop operation to leave something from the top to remove something from the top. What is the sequence of the operation at the stack is leave for last in first out. The last item that comes it goes first. Application of the stack are reverse reward, undo operation in text editor, backtracking, and language processing. The next is the queue. Queue is where it comes the data. Queues are also used to store the data, where the first is the element that comes first, it leaves first, and the element that comes last, it goes out last. So the array are called as FIFO, first in and first out. Applications of the arrays are operating system often maintain a queue of process. In operating system, the pending operations are stored in the form of a queue, and whenever their priority comes, then they are addressed. And buffer, they are an example of the queue. So the trees also have the example that are a kind of data structure where there is a root, and then there are the child, and there are the child, and this is the example of a tree. So organogram, sorting and searching and relationship, these are the example of the trees. Then it comes the graphs. It is also a data structure where they have the graph G is a composed of which is composed of many nodes and vertices, and nodes and vertices they depict some relationship. Modeling a road network with vertices as town and edge cost distances. Modeling a water supply network, dynamically modeling the status of a set of routes, traffic directed over the internet, minimizing the cost and time taken for the air travel. So all these are the examples of the graph. So basic operations performed on data structure are traversing, searching, inserting, deleting, sorting, merging, update. Traversing, it is used to access data, each data item exactly once so that it can be processed. Searching, it is used to find out the location of data item if it exists in the given collection of data. Inserting, it is used to add a new data item in the given collection of data items. Deleting it is used to delete an existing data item from the given collection of data. Sorting it is used to arrange the data item in some order in ascending or descending order. Merging it is used to combine the data items of two sorted files into a single sorted form. Update an element at a given index. So characteristics of data structures: arrays, they are quick inserts and fast access of index, but arrays are slow search and slow delete, fixed size, stack, last in, first out, slow access to other items, queues, first in, first out, slow access to other items, linked list, quick insert and deletes, quick deletes, slow search, binary tree, quick search, quick insert, quick delete. Deletion algorithm is complex graph, best models, real world situation. Some algorithms are slow and very complex. Types of data structure. Data structure can be following types: linear data structures and non-linear data structure. Linear data structure. In these data structures, the elements form a sequence, such as array, linked list, stacks, queues, are linear data structures. Nonlinear data structures. In these data structures, the elements do not form a sequence, such as trees and graphs are nonlinear data structures. So abstract data type editing. An abstract data type combines the description of data structure and associated operations. Abstract data type has following characteristics: provide a description of element in terms of data types, defines the relationship among individual elements, valid operations and parameters to be passed, error conditions associated with operations. So abstract data type have operation, data structure, and error conditions. Uh, for example, an abstract data type can be defined by packaging together the following operations: push inserts an item into the stack, pop returns a stack from the stack, peek returns the topmost element without removing it from the stack, size returns number of elements currently in the stack, is empty returns if stack is empty and false otherwise. Abstract data type. Set of operations associated with abstract data type is called interface. Elements of abstract data type structures are manipulated through an interface. Figure shows how elements of abstract data types are accessed using interface. The implementation of operations and data items are hidden from the application program. Application program, abstract data type, pop, push, peek, is empty, size, they are the stack data. Abstract data type, all built-in primitive data types are in fact abstract data types. In floating point, for example, we cannot add a new operation, say exponentiation. We cannot enhance or shrink the set of allowed values. Abstract data types specify how the data structure would be coded. It does not describe whether the data elements are stored in consecutive or disjoint operations. The implementation details are hidden from the application program. Abstract data type. In software module, abstract data type can be viewed as a layer between application that uses it and a component that implements abstract data type. Some high-level languages provide support for abstract data type in different ways. C has built-in structure type. In C++, a class construct can be used. In Java, abstract data type can be expressed as an interface. So some implementation layer, abstract data type layer, and application layer. So this is the hierarchy. So next we will review the basic concepts from object-oriented programming language. Thank you so much. Thank you.